So how does this chameleon-like wonder come to life? It starts small.
These beads, before they come to us, they're processed in reactors, and they're 15,000-gallon reactors, and styrene is a liquid. They dump about approximately 6,000 pounds of styrene in here, and they dump about 3,000 pounds of water, and it's just like oil and water. They don't mix. The faster you agitate it, the smaller the balls you get, and that's where we get these small beads.
The beads then begin a multi-step process, which starts at the pre-expander. It's here that the beads begin their amazing physical transformation, when the pentane inside them changes from a liquid to a gas.
The polystyrene sits on the floor, and the steam comes up from the bottom of the floor, and that's what reacts with that pentane. The beads get conditioned, they get worked, that bead gets soft, and it starts to expand with that pentane gas releasing, the beads expand.
The beads ultimately grow to 40 times their original size. The machine can be set for different recipes based on the amount of beads used. A lighter mixture would be made for packing materials, a denser, tougher one for road use.
The higher the density, the stronger it is, the more weight there is, the more wear and tear it can have.
The beads then take a break in storage silos, where they lose some of their pentane gas, making them easier to mold into solid forms. The block mold, with its internal vacuum, is where all the action happens for the foam's final metamorphosis. It's where the hyperactive beads start to take on their new role as usable, durable foam.
We're going to stick it in the block mold, and we're going to make a 2-foot by 4-foot by 16-foot long block. The beads are going to get together, and when you hit it with heat, steam, it's going to want to expand, but there's nowhere for it to go. So what it's going to do is it's going to mold itself together. It's going to fuse itself together, and you're going to have a finished block when you're done.
The final blocks often tower over the workers who move them. They are now tough enough to support major highway projects. Or they can be sliced down thin enough for delicate packing material. Another reason the finished product is built to last is its recyclable properties.
We recycle probably over 500,000 pounds of EPS a year in our facility. We take it back from consumers. We got a lot of post-consumer product here. Take it back from appliance stores. We recycle 100% of our stuff.
Over 69 million pounds of EPS foam was recycled nationwide in 2008. But foam's long-lasting use in roads and bridges could be its most valuable legacy.
It doesn't disintegrate, it does not break down. It's just like it was if you dig it up 20 years from now. It's the same as when you put it in the ground. Foam is here to stay. It's built to last.